last video, we looked at discrete random variables and we dealt with being able to express them in a possibility space. That's like those tables that we did where we had the different values on in the first row, and then underneath that the probability for each of those values. Today we're going to look at how these can be expressed as a probability function, and we'll learn how to turn a probability function into a possibility space. So I've got an example here that is in your exercise book, in your textbook, and it's this. We've got this strange looking language here, PR bracket x equals r equals kr, and then we're given these values of r off to the side here. Well, what does this all mean? Okay, well, essentially what it means is we're looking at the probability that x takes a particular value r, and the probability of each of those values is a constant k times the value r. So let's fill in a possibility space for this. R can take four values, 1, 2, 3, or 4. And we know that the probability of each of those values is k times r. So k times 1 is k times 2 is 2k, 3k and 4k are our other options. Now, because this is a discrete random variable, we know that these values of k must add up to 1. So if I add my values of k, I've got 4, 7, 9, I've got 10k. So 10k is equal to 1, and therefore I know that k is equal to 0.1. So I can fill in my actual probabilities in the bottom level here: 0.1, 0.2, 0.3, 0.4. So that's kind of a little bit of an introduction to how to do these. I'll try a few examples from the exercise, and then I think you should be able to get on with these yourself. Question 1 says, which of the following could not be the probability function of a random variable? For those which could be, find the probability distribution. Well, I'm just going to do one from this. Okay, so I've got the probability of random variable x taking values r is k over r plus 1. So let's set up our table here. We'll have r, and the values that we can have are 1, 2, 3, 4. And we know that the probabilities are k over r plus 1. So this one would be k over 2. This one would be k over 3. This one would be k over 4. And this one would be k over 5, the probability. All right. Now, we need to figure out what k is equal to. So I'm going to add all of these values together. So we're going to sum them. And that means when we do that, we're probably going to need to have them all in the same denominator. Now, I suggest for this, what do they all go into? Well, we could just multiply them all together. We could all go into 60. So we'll put them into 60ths. Okay? Now, 2 halves into 60th is going to be 30. 3s into 60th, thirds, so that'll be 20 60ths. 4s into 60, so that's 15, so we add 15 there. And 5s into 60 is 12. So we add all of those. That's a plus, by the way. We add them all together: 30, 50, 65, 75, 77. So it all adds up to 77 over 60. Okay, so we've got 77k over 60, and that must be equal to 1, using our rule that all the probabilities must add to 1. So therefore k is going to be equal to 60 over 77. I just multiply both sides by 60, then divided by 77 to get the k by itself. And at that point, I can now chuck this value into here. So 60 over 77 divided by 2, which will give me 30 over 77. This value here would be 60 over 77 divided by 3, so this will be 20 over 77. 60 over 77 divided by 4, which will be 15 over 77. And then my final one, 60 over 77 divided by 5 will be 12 over 77. So I've now got my actual probabilities in this last line here. Okay, now we're going to do D from part 2, I think. List the probability distribution for the for this probability function. Probability that h is equal to a value r is equal to k times 2r minus 1. So again, let's just list our possible values. We've got r, we can have 1, 2, 3, or 4. And we know that the probability will be k times, in this case, 2 times 1 is 2 minus 1 is 1. So we're going to have k here. The next one is 2 times 2. So 2 times 2 is 4 minus 1 is 3. So this will be 3k. And you should sense a pattern here. 3 times 2 minus 1 is going to be 5. So this is 5k. And you see the pattern here. This last one will be 7k. Now we know that these values must add up to 1. Now if I add them, I get 7 and 5 is 12, and 3 is 15, and 1 is 16. So 16k equals 1. So k is equal to 1/16. So I can chuck these values in here. This is 1/16. 3k must be 3/16. 5k must be 5/16. And 7k must be 7/16. And my last step would be to write P H equals R. So that's that last line of my table. Whoops, undo. Okay, now moving on to the last question I have for you today. Okay, this last question, we've got x is a discrete random variable with a probability function PR. X equals x is x over 15 for the following values of x, 1, 2, 3, 4, 5. And we've got A is event x is greater than or equal to 3, and B is another event x is less than 4. And we've got to find these different probabilities. Well, my first step is to set up a possibility space. So here we go. X, I've got 1, 2, 3, 4, and 5. And my probabilities are simple. In this case, we've got no constant, so this is just 1/15, because it says x over 15, 2/15, that's a 3, 3/15, 4/15, and finally 5/15. Okay, now, first of all, A. What is the probability of A? Well, A is x is greater than or equal to 3, so that is these ones here. So we've got 3, 4, and 5. So this is 12/15. B, what is the probability of B? Well, B is x is less than 4. So that is speaking about these events. So we've got 3, that's a horrible 3 there. 3, 4, 5, 6. So we should have for this one 6/15. Okay, now C. Probability of A intersection B. In other words, where is it both A and B? Well, less than 4 as well as greater than or equal to 3. So that intersection is this bit here. So P, A intersection B is going to be 3/15. Next, D. We need to find the probability of A given B. Now this is your conditional probability, and you know the formula for that. You want probability A intersection B all over probability of B. In our case, what we have here is 3/15, which we got from part C, and divide that by the probability of B, which we got as 6/15. You can see that your 15ths are going to cancel out, so you get 3/6 or you could say 1/2. Finally, E, the probability of B intersection A. Now we know, using our conditional probability formula, that that is equal to the probability of B intersection A all over the probability of A. And we know the probability of B intersection A is 3/15. And we know the probability of A is 12/15. So we're going 3/15 divided by 12/15. They cancel out. We get 3 over 12, which is, of course, 1/4. So that should be enough information to help you have a go at exercise 5.2. Do let me know if you have any difficulties with this exercise. God bless.